Hello everyone, it's a software case study, IGNO-GovKZ, and it's a large-scale government P2B and P2G platform that automates export and import processes. The system supports electronic document submission, issuance of licenses and certificates, and integration with multiple government databases. The main users are entrepreneurs, customs broker, and government officials. The platform handles thousands of users, and high availability is critical. Even short downtime affects logistics chains and business operation across the country. So, the system was originally built as a monolith. Over time, four key issues emerged. First, tight coupling. The code base became highly interconnected. Changes in one module could break others. Second, no independent scaling. High-level modules could not be scaled separately. And third, downtime during releases. Even small updates required stopping the entire system. For outdated technology stack, development slowed down and hiring became more difficult. For for this limitation made architectural change necessary. And the target architecture is microservices. A full system rewrite was rejected due to high risk and potential downtime. Instead, the Strangler weak pattern was chosen. This approach replaces the system gradually while keeping the original system running. An API gateway is introduced as a single entry point. Requests are routed dynamically and to microservices if the model is migrated. So over time, the monolith becomes smaller as independent services take over functionality. The migration is performed step by step. Step 1, API gateway setup. All traffic is initially routed to the monolith. Step 2, a new microservice is created using Spring Boot for dictionary logic. And step 3, routing configuration. Requests to API dictionaries are redirected to the microservices. All other requests remain in the monolith. Step 4, the process is repeated for each module, and the monolith gradually shrinks while microservices expand. The Strangler weak pattern ensures zero downtime during migration. The API gateway acts as a single entry point for routing and GWT validation. Database preparation is handled gradually using SQL views and Kafka synchronization. Authentication is centralized. GWT tokens are validated at the gateway and passed to all services. Observability is implemented using ALK, stack, and trigger. The first challenge is database separation. The monolith relied on a single shared database. The solution is a two-step approach. First, SQL views for safe data access, when gradual migration to separate databases with Kafka-based synchronization. The second challenge is session management. Server-side sessions do not work as distributed systems, and the solution is GWT-based authentication handled by the API gateway. User identity is passed through HTTP headers. So, iterative migration reduces risk and maintains system availability. The Strangler weak pattern avoids high risk for rewrites. Observability is essential in distributed systems. Database separation must be gradual. Future improvements include a modern frontend and API first architecture. So it's originally screen from project, and request by demonstration request flow for the system. Our client sends a request and the API gateway validation GWT token. Our routing decision is made based on the request path. So the request is forwarded to a microservice or the monolith. The process is fully transparent to the user. Tech stack. Legacy system Java 8, GSV, shared databases, and API Gateway engines or Spring Cloud Gateway, microservices, Spring Boot, REST APIs, and PostgreSQL, infrastructure, Apache Kafka, ELK stack, Jagger, and Docker. The key architectural decision is transfer instead of a full rewrite. So thank you for your attention.